Building an event-driven architecture? Is your database a bottleneck? Consider RavenDB. Indexes are compiled ahead of time, making your queries up to 3,000 times faster at runtime. With support for distributed transactions, real-time data, and ETL for Kafka and SQL Server, RavenDB won't be your bottleneck. Learn more at ravendb.net.
Hi, everyone. Before we start today's podcast, I wanted to tell you about QCon London 2024. Our International Software Development Conference takes place in the heart of London this April 8th to the 10th. Uncover senior practitioners' points of view on emerging trends and best practices across topics like AI software architectures, generative AI, platform engineering, and modern software security. Explore what they've learned, techniques they've discovered, and the pitfalls to avoid to validate your ideas and plans. I'll be there hosting a track on connecting systems with speakers talking about APIs, protocols, and observability. Learn more at qconlondon.com. We hope to see you there. Hello, and welcome to the InfoQ podcast. I'm Thomas Betts, and today we'll be discussing the current trends in software architecture and design for 2024. The InfoQ editors on today's panel are Eran Stiller, Rafal Goncalves, Daniel Bryant, and our special guest is Blanca Garcia-Gil, a member of QCon London Programming Committee. Let's go around and do quick introductions, and that way our listeners can recognize your voices. I'm going to start with Eran.
Hi everyone, my name is Eran Stiller. I'm a principal software architect at Luxury Escapes, and I'm an editor on architecture and design in InfoQ, I think for the last 3 or 4 years. I've been enjoying quite a lot. I've been doing architecture and design issues for like 20 years. And this podcast is one of my highlights of the year, so I'm looking forward to it.
Rafal.
Hi everybody, my name is Rafał Goncalves, and I've become an InfoQ editor only last year, so I'm reasonably new to this group of people, and it's my first podcast as well, so thanks for having me. I'm working as a principal engineer at Starbucks and have been a user of InfoQ for many, many years.
Daniel.
Hi everyone, Daniel Bryant, a fellow co-host of the InfoQ podcast, along with Thomas and several other folks too. My day job, I'm an independent tech consultant, long-time architect, part-time platform engineer, bit of DevRel in the mix too, and I also manage the news at InfoQ.
And last, Blanca.
Hi everyone, my name is Blanca Garcia-Gil. I currently work as an independent data consultant, but I have a background in software and data engineering. I'm also a programming committee member for QCon London, and I'm very excited to be here today.
Thanks. And since I guess I haven't done my introduction in a while, my day job, I'm a principal architect at Blackbaud, which is the largest software provider for the social good community. Been an InfoQ editor and now the lead editor at InfoQ for architecture design for 7 or 8 years, I think. Been the co-host for the podcast for a little while and also do a lot of stuff with various QCons in London and San Francisco. So I meet a lot of these people in real life on a regular basis. All right, so today's discussion is a component of the 2024 Architecture and Designs Trends Report. One of the regular features of InfoQ are these trend reports, and each one focuses on a different aspect of software development. The reports provide InfoQ readers with a high-level overview of the topics you should be paying attention to that year, and also help the editorial team focus on innovative technologies across all the content on InfoQ. This conversation is just that one half, so please go and check out the report that'll be available the same day that this podcast is online. I'm going to start our discussion talking about data-driven architectures, because one of the things we've noticed a lot in the last few months especially is InfoQ news items that talk about architecture also talk a lot about data, and these big data systems are becoming more and more important for architects to be considering as we're designing them. You have to consider whether it's ML models or analytic models or just all the big data we have. So it's kind of that big bucket, and it's been a topic we've covered in different ways. And I just wanted us to have a discussion today about how the different ways that data is affecting architecture decisions. And Blanca, since you mentioned your data in your bio, I'm going to start with you.
Thank you, Thomas. Because in my career, I started actually working in software engineering, and then I moved into data. It felt like there were two different worlds and almost good software principles that I learned in my career. When I started working in data architecture, I was thinking, well, a lot of these things are really the same. But then people were coming from a very different place working in data, because data systems used to be kind of handled completely separately in organizations. So nowadays, architects are thinking more about these things that are actually going through the pipelines, going through the microservices, which is the data points, and thinking, what are the things that I need to kind of think about this data? So things such as, how do we keep this data secure? How do we make sure this data has a certain quality so then downstream systems can consume it? And more on the topic later, what is consuming this data point? So there are all these concerns about data that they used to be kind of handled by separate teams or separate systems altogether, and now being handled by the architects. And I think this is really good because there's a lot of learning kind of both ways. And there's also kind of expectations for the data to be to a certain standard, whereas before maybe we tolerated the data not being so good, but now we want to make really good decisions with it. And also, there's an expectation that the systems that hold data for business consumption, they kind of almost like have this resiliency to them. They're always available. And a lot of the things that before were not as important when kind of coming up with data solutions.
Yeah, I think the fact that it's part of the main workflow and the main pipeline, it's been slowly progressing that way. But it used to be, oh, that report runs once a night. And if it didn't run that one night, well, it'll run tomorrow and it's fine. Or it'll take 2 hours to run. And now you need that to be instantaneous, always on, and always resilient, so that if it goes down, it comes back up. So has everyone else seen similar trends of how what you need in your main system, your operation system, is now affecting how you have to maintain your data architecture?
I have to say that I've certainly observed more emphasis on data architectures or architectures that support machine learning workflows. And that's not only to provide training, but also be able to serve data, serve models, do model versioning, and basically be able to support the entire life cycle of delivering training and then serving models. Those systems are getting more and more sophisticated, and you can certainly observe that there is much more attention to various architectural qualities, including the way that those systems are composed, the resiliency, observability, and obviously performance, among other things.
I think as architects, we always need to know quite a lot of things about various areas. And this is quite a big one that we need to know today. Like we have all these tools and concepts like data lakes, data warehouses, ETL tools, data quality tools, you name it. And it's an entire area that we really need to be aware of. Like some of us like deal with it more in our day-to-day works, some of us deal with it less, but it's something we can't just ignore. Like we really need to be aware of it, and we need to integrate it into our system. Like for example, you mentioned, Thomas, like today we can't get our data like once a day, like get a report, like an ETL pipeline, that's it. Let's say we're running some microservices system and we have a lot of databases. How do we get the data from the databases to where that report is generated? We can use ETL pipelines, and then we have a direct dependency on the database. We can use something like event-based architecture and have it the application layer. Each architecture has its pros and cons, but it's all tied up together and really taken into account when we build our systems.
What I'm hearing, what I'm seeing as well is like, to mangle the William Gibson quote, architecture's here, it's just unevenly distributed. Do you know what I mean? As in, like, I remember just as we kind of figured out architecture for software applications, like we mentioned off micro domain-driven design, microservices, now we're struggling with data, right? Maybe we'll touch about platforms later on. I think that's one of the key things, like architecture flows through all the things in our systems, but to varying degrees of maturity. And I think that's the biggest, like, think of like the trends report as well. The biggest challenge is identifying the thing you're working on. Where is it in the maturity level? Do you know what I mean? Like, we're pretty good at architecture and software, I think, now, right? But data, as in to Blanca's point, like the quality and the reliability and all the ilities, like we're not so good with, right? And I think that's where I'm seeing like the shift in focus now.
Yeah, architects are always concerned with those quality attributes. And it used to be, these are the quality attributes of my software system. And that big data stuff is off to the side. And so it's allowed to have different quality attributes. And as it gets more and more incorporated into my primary workflow, part of that is it has to come up to the same level of quality. It has to have the resiliency. It has to have the uptime and the SLAs. And so I like the idea of those terms you have to know about. Like I think Ron mentioned, like you need to know more stuff. Well, I didn't have to be concerned with those things, but as they get pulled in, now it's all in your domain. So architects have to be concerned with a little bit more knowledge about everything. I think that's going to be a nice sort of segue because we have to talk about large language models. I think it's required now on every podcast to talk about AI and ML and LLMs. Where does that fit in with architecture? Is there a big trend around LLMs for architects to be concerned with, or is it all just hype?
I don't think it's just hype. Like last year, if I remember a podcast, it was the main theme of the podcast because it was brand new at the time. And I think we all learned a lot and grew up over the past year. And I think everyone's using it, as in it's another tool that we can use. Like if you have a component that or some functionality that you build, you can leverage Gen AI, if that's what we're talking about, in that context to generate some result, to build some new functionality that you couldn't do before. It was much harder to do before. But I think it's another tool. It doesn't change necessarily the way we do architecture, unless you take into account that for some AI models, that's not necessarily Gen AI, but more general ML AI models that fits into the data theme we discussed before, when you need to collect the data, not just to report on it, but to train and serve models. So that's where it all fits in my view.
Yes, and I think there will be certainly more and more integration happening between the AI-enabled driven components and other components within architectures. Obviously, at the moment, we are still, I would imagine, in the sort of experimental phase, but a lot of these things will get productionized or are being productionized, and this is where the architecture of focus, I think, is going to come into play.
I agree with Rafal. I think organizations and engineers and architects it's vital that we get to grips with the possibilities of this and kind of gaining understanding of what we can do. And I expect more and more companies to come up with their own kind of custom LLMs to solve their own kind of problems, because even the open source frameworks are out there. So you can do some of the training yourself and just play with things. It's very kind of low friction.
Yeah, I think that's where you're going to see, once people figure out how to make it easy for their own specific custom implementation, how do I train an LLM on my data so it understands what I need? We've seen a few uses of, I can point something else at your document history or whatever, and I can find the PDF that's applicable. Microsoft Copilot's one of those things. There's others out there. Like, here's how to scan just your data as opposed to look at the internet. And I think we're going to see those things get more tailored. And so the LLM will just be one more tool that you can then say, I'm going to plug this in as part of my system. But I don't think it's going to become our entire system is an LLM and an AI, and we don't know how it works. I don't think that's going to happen. I also appreciate, Eran, you mentioned this is a tool for the architects, because architects do two things, right? We design the systems, but we actually also practice architecture. So there's what we draw as the boxes and arrows and the decisions we make, and then it's how do we make the decisions? And finding ChatGPTs and other things as the rubber duck. I'm going to have one more person to ask questions and bounce ideas off of. Don't turn your designs entirely over to it, but it's one more person you can ask rather than I can get on a phone call with you all and say, what are we going to talk about?
Last year, I think one of the discussions we had was, or everyone had basically, will it replace developers? Will it take all of our jobs? And I think that discussion kind of died in the past year, since we all learned that, like you said, Thomas, this is a tool. I think actually Microsoft's name for it, Copilot, is good. That's the Copilot. We're still the pilots, and it's another tool. And I love using ChatGPT and Copilot to write some code that, let's say I need to write some bash script that does something, and I don't remember like bash syntax by heart, but I can let it write the code for me. It does 90% of the job, and then I just need to fine tune it and fix the things that I need. The same thing goes for architecture. It won't come up with the architecture, but if we come up with some designs and ideas, it can be a good idea, good way to validate them.
But also, I think maybe by extension, I would say that since we are in the business of essentially broadcasting, sharing knowledge, right, to other people who are perhaps looking to InfoQ for inspiration and learning new techniques or new tools, new technologies, I think AI in the context of architecture and engineering in general, I think has got a potential of be the enabler, I guess, for learning. In a sense that as we are trying to compile the experience of our people and present it to others, I think to a certain extent AI might actually do reasonably good job at either applying well-known, well-established patterns to certain problems without actually having a human to try to figure out how to apply a pattern or a design style. And similarly, I think in sense of capturing, categorizing, analyzing, and deriving insight from knowledge that is available out there.
I'm looking forward to the explainability, Rafal, to that point as well. I think we talked about this on the podcast last year, but like combining the ability to look at your Git history, like your ADRs, your architecture decision records, and just the code base in general. I've played around a little bit on my very small code bases. I imagine like the big banks and other financial institutions and just, big institutions in general, like you can't replace that code overnight. It's going to be decades probably in the migration, right? So the ability to say, hey, Copilot, as Eran said, please analyze this part of the code base, tell me where this change will need to be enacted, or explain to me the structure used. Because honestly, when I was like doing Java projects, half the battle was understanding the models in the code, and the person before me, or even me at times, what I'd written at like that point a year ago, right? And it's like, explain it back to me like I'm 5. I'm really looking forward to that, like proper explainability. I think that's the next gen for me in terms of that Copilot for like architects.
Yeah, I'd like to add one more thing to that explainability, and is we need to be able to trust these models. That's kind of the key foundation that you build everything on, because otherwise, you you don't really know if you're going in the direction you want to go, or the model is just basically saying something, and then you need to be able to kind of question it and wonder, is this really what I need?
Yeah, I think this is a general caveat, I guess, and challenge with AI. Obviously, depending on what you feed it, you'll get different outputs. And, there are all sorts of biases. I mean, humans have biases. Artificial intelligences will have lots of biases, even more so, I think. So, yeah, everything has to be taken with a pinch of salt. And it's just an advice like any other. We are not, let's say, we are not supposed to stop thinking, right? It's particularly architects that I think we pride ourselves about, thinking and maybe overthinking things as we go about our work.
Yeah, I think the co-pilot versus the pilot, like you're still in charge. Remember that. It might look like it knows what it's talking about. It's just guessing the next word in the sentence. Like you go back to what does it actually do? It doesn't know anything, but it really appears like it does. And that gives that false sense of, well, it sure seems confident. I like the trust but verify. Like, is that a good idea? But how do I actually know? Just like if I asked another person, but I'm still the one responsible for making the decision, I'm just getting other input and other ideas. I have to make the decision. It's my name going down there. I'm not signing off the ADR. Well, ChatGPT said so.
Yeah,
And my
that's a good
name on it.
point.
No.
Let's move on to a different topic. Cell-based architecture. We had a couple different articles. I think Ron and Rafal both wrote on InfoQ just in the last month or two. And Daniel, you found a presentation or an article from like 2019. So I guess, what is cell-based architecture? Why is it making a resurgence if we've had it for so long? What is it and why are people using it? Why is it important right now? Ron?
Maybe let's explain it first. So cell-based architecture is basically a concept where you take a running system, you basically put it apart into components or cells, as they're called, and each cell can operate independently. So once a request goes into the system, it gets routed into one of these cells. You could think of it as an availability zone on the cloud, or it could be a data center or something else. But once the request gets in, it gets entirely served from that cell. Now, even if other cells drop off, they have issues, whatever, the cell is independent, can keep running, and it can return response to that request. Now, the reason that's important is that when we're building cloud-based system, cloud native, microservices, write-out services, whatever we call it, we have a lot of dependencies, we have a lot of moving parts. And when a request comes in, it can travel through many, many, many components in a way. And the more components we have, the more probability that something will fail. And once we model it as a cell, and we know that either a cell is working and then it gets requests, or we identify that it doesn't and we don't route any more requests to it, it really lowers the probability of any errors happening. Now, this is not a new concept. We used to call it bulkhead pattern like before, so you could think of it as a rebranded thing. But I think with the resurgence of cloud native and more complex architecture, this is like making a comeback to reduce the probability of errors and improving the user experience eventually.
Well, yes, I think I've actually linked to an article from 2012. So the actual first mention of it, I think it's much older than even we think. And it's kind of interesting because it has researched in the context of the cloud, obviously, since a lot of companies are running their workloads on the cloud. And I think there are specific challenges regarding, for instance, gray failures, where you have your various layers of your services, let's say. It's supposedly a bad pattern to have services call other services in layers, but people still do it. And obviously we have databases, we have other infrastructure level services. All of that turns into a lot of interactions, usually spanning multiple data centers, which is all great for resiliency, but it's difficult to detect if networking issues, for instance, between those data centers or availability zones. So this is one of the elements where companies, and particularly large companies that cannot afford to experience partial failures, and obviously detecting and addressing those is quite challenging. Those companies have, I think, brought this concept up from, the archive, so to speak, and started adopting in the context of cloud-based workloads. Another element which I think drives this quite a lot is the fact that I think on most public cloud providers, you usually get charged for any traffic between availability zones or the data centers. So actually constricting your traffic or the interactions between services and other architectural components to a single cell that is collocated in a single DC saves you some money as well. So that's another element around cost effectiveness and sustainability.
In the cloud, you can easily spin up more and more servers and services, and you can spin them up in other availability zones, other data centers. Like, it gets relatively easy to just write the script to just do that. And there's been that thought that if I have more, I'm more resilient, right? And we've seen many cases where that doesn't prove out to be true. And you have one little failure, and because you didn't write good isolation and good fault tolerance and bulkheads and follow those patterns, that one little thing just spills out and goes past that availability center and goes into another data center. So the idea was, if Amazon East goes out, I'm still up on the West Coast, but that's an Amazon problem. That's an AWS problem. Your problem is your code took down all of your servers and your services. Like, Amazon's still up and they're fine, but your code had this little bug and it spread out, and you had the query of death scenario. And I think that also gets to your point about cost. Like, we didn't need to spend all the money. It didn't actually buy us anything. And we're sending traffic back and forth. It doesn't need to be there. So I can isolate it, save some money, make my systems more resilient, but I do have to think about it. It doesn't come for free. And that's where all this comes in, is I'm going to call it a cell-based architecture, call it a bulkhead pattern, but I'm going to specifically put that into my architecture. Ron, you have something to add?
Yeah, so Rafal mentioned the data saving aspect, and there's also the resiliency aspect. Now, when you think about resiliency, we had tools in the past to do this. Like, you think about the circuit breaker pattern. That's exactly what I meant to do. If you have a failure in a specific service, you want to stop it from cascading to the rest of your system. And cell-based architecture, another way of doing it, it has other advantages, but you really have to think about the way you lay out your architecture and how you define the boundaries and how you enforce them. So it's not easy, but it has its advantages, and I suspect we'll see more and more companies do it over time.
Yeah, one thing to add to that is that you have to ensure that you have a good way of routing your requests to cell. So this is where the complexity comes in. I think once you are in the cell, everything is simple, quite isolated, but you need to make sure that you have consistent way of routing and obviously detecting cell failures to avoid traffic being sent there.
Nothing comes for free, but if you do it right, you can save some money. I think the other thing that this related to, in my head at least, was the general idea of where are we on the monolith to microservices and back again, and we're going to go full Lambdas, we're going to go serverless, we're going to go back to servers and EC2. There's been a few stories of this. It keeps coming up. It's an interesting thing for the trends report, because everything that people are going back to isn't a new idea, but I think there's still something to be said about the companies still constantly reevaluating your architecture and having that continuous architecture mindset of whatever decision we make might be good right now, but we have to constantly come back and evaluate it. And so maybe we need to go to a cell-based architecture. Maybe we need to do monoliths instead of too many microservices or Lambda functions. I think was it Rafal, you were going to mention the Modern Architecture book by Nick Toon? Was that kind of in the same vein of architecture modernization?
Somewhat related, I think, although I think what I like about it is the fact that it actually expands system architecture into what I think Nick calls a corporate architecture. So I think for me, it's a kind of a natural progression, I think, that started with the agile movement and maybe then turned into DevOps. And now I think inevitably, obviously, we want, or companies want, better services, better products. The best way to do it is to align what you do with the outcomes you are hoping to achieve. And that's usually being competitive in the marketplace. So the same way that Agile and DevOps, I think, enable teams to pursue their goals within I would say, the restrictions of the specific areas that they are operating. What I like about the approach that has been promoted by Team Topology's book, a very good one, well recommended. And now I think Nick, who is with his architecture modernization book, is expanding beyond that, combining it with a lot of data-driven design and other concepts that I think have been maturing up over the years to provide essentially a framework that allows to bring together product development, architecture, as well as organizational structuring or creating technology organizations. So I think that's going to have quite a profound impact on the industry because it actually provides good patterns to follow. And like we talked about, maybe doing, DevOps between, it was actually called DevOps. I'm sensing that we are in one of those moments where there's something that is being called, and maybe there's going to be a better name for it, because obviously we are constantly modernizing our architectures. But I think a path or the drive towards kind of unification and alignment between the technology and business, I think it's what drives it. And Nick provides good patterns and good way of going about implementing something like that at the level of, companies and business units.
You're bringing up a good point about getting all the different viewpoints together. Architects always have to talk to all the different stakeholders. So when we start incorporating all that into our products, well, like that was what Agile was. It was have more communication. Don't just write it down and throw it over the wall. DevOps, don't just write the code and throw it over the wall. Like get together and talk with the people. And that leads to, when we have that mindset, it leads to better software. And I think you started to talk about that gets to how do we deploy and integrate our software. And so I'm going to use that as a nice softball over to Daniel to talk about where are we at with platform engineering, because I feel like that is a thing that architects need to be considering is how are we going to build the software? How are we going to deploy the software? How are we going to run the software? And that's where the platform becomes a key factor, right?
Hey, Thomas, and Raphael, you've queued me up perfectly with the mention of team topologies, right? And we should mention Matthew and Manuel are friends of InfoQ, and they are awesome. And that book has just done so well. It's like super happy for them. It was like I saw it being birthed, and it was just a really nice like culmination of all the patterns coming together and fantastic work. And I think like two things to platform engineering. I see the platform you build influences the architecture you choose. Like if it's really hard to spin up new services, or you're bumping into incidents all the time, you're incentivized perhaps not to create new services, right? So you just jam the code in the existing services, or you go back to the monolith. I'm not saying it's bad or good, but the platform is like a symbiotic kind of vibe with the architecture, the application, the infrastructure itself. Like the way I'm looking at things at the moment is like there's the application layer, there's the platform layer, and the infrastructure layer. Not everyone likes that pitch. I'm kind of like working with the CNCF and a bunch of other folks, like trying to understand how to build better platforms, but that's sort of coming full circle. And as much as the platforms influence the architecture, a lot to learn, I think, from architecture, all the good stuff we've been talking about, into platforms like the layering, the abstractions. Like we've sort of hinted at it several times in the call, like classic stuff, like things like coupling and cohesion, like that's just universal, right? Whether we call it, label it something or whatever, but so many times in my career, like whether it's testing, whether it's like infrastructure, whether it's design, applications, I'm like, coupling and cohesion here. And I just think, like I mentioned earlier on, architecture sort of like is here but not evenly distributed. Same vibe with the platforms. I think there's a lot of things me as my software engineering background can share with the platform folks. Definitely a lot I can learn from the platform folks, back to software application design as well. But that's kind of think where we're at the moment. In terms of on this sort of curve, like diffusion of innovation that we constantly talk about, platform engineering is still quite early days, particularly in relation to architecture. So probably like innovators kind of thing, right? I think everyone's kind of adopting a platform or a portal. Probably I see a lot of people doing Backstage and other things like that. That's not necessarily a platform. I like Backstage. I think it's really good tech, but I think it's different than platforms. But I think early days for us getting our head around how to build platforms and how the platform influences architecture too.
Yes, I think I would agree with that. You can certainly see a lot of thinking and a lot of effort going into building those systems. I mean, these are systems like any other systems. It just happens that they are supporting building the actual systems that the clients or customers are using. But they are, well, actually in that regard, they are perhaps even more important than what your product might be, because they have a multiplying effect. If you have a bad platform to contend with, like you said, Daniel, you will end up perhaps sacrificing your architectural options, because you might not be able to support your chosen architecture in terms of the ease of deployments, for instance, and be it resiliency or failover options and so on, or observability, which is a must in the era of microservices, for instance. So what I'm observing certainly, and it's kind of interesting, and it's been going for years and years, we just didn't have a name for it again, because obviously, there was some sort of CI/CD or maybe CI at the time, and then throwing it over the fence. But then, CI/CD, and things are obviously getting better and more sophisticated. And now we are looking at essentially complete pipelines and life cycles for software delivery that combine a lot of maybe lower level products, because everything is API driven or has some sort of interface. So a lot of folks, ops and dev alike, end up being essentially, both designers and architects of those systems. So certainly architectural principles, I guess, you name coupling and cohesion and, all manners of naming things and structuring composition and so on are good things to bear in mind.
About what Rafal mentioned, he mentioned that everything has an API. I'd like us to look at another take on this where everything is becoming code. So we heard about infrastructure as code like for a while and have like multiple Terraform, Pulumi, various platforms that do it. We now have CI/CD as code with things like Dagger. Although again, the concept existed before. Like we configured CI/CD pipelines like in code for a long time. And once everything becomes code, software architecture principles start applying on it. So for example, if you look at your deployment pipelines or your deployment methodology, let's say you built a microservices system. The deployment itself can be a monolith. It can be in a monorepo. It can be multiple repos. It can be distributed, so every part of the system gets deployed and tested independently. There's a lot of decisions to be made here. And I think this is another area that architects should be aware of. They can't completely ignore and say, oh, this is the DevOps, this is the platform engineering, that's their problem. No, it's our problem as well.
I think the same goes to the data as well. I was going to say, like, throwing to you, Blanca, as in, like, the data here, right, is really key. As in, like, sort of, like, not quite data as code, but as in, like, data mesh we've sort of talked about off mic, that kind of thing. I was kind of curious what your experience is like. Are the CI/CD pipelines, are the platforms in the data space as good as the other platforms?
I think it's coming a long way. So my most recent experience has been working in teams that are made up of people with very different backgrounds. So people who come from like long time working in data, also people coming long time working in software architecture. And when you get all those people working together, is when you can achieve the best of both worlds. I think there's still organizations that these things are still a bit separate, but I think the trend is more kind of coming together.
That's where I go back to, we need a name for it because everything works better when we have a name. Before it was called DevOps, they were just high-performing teams. Like the teams just talk to each other. I worked in organizations where you only had a few people and you kind of had to be the chief cook and bottle washer. Like you did everything. So I became really good at running the server and writing the code because no one else was around, right? And now you get to bigger companies and you had these silos and you look at team topologies and its idea is like, you got to break down the silos. Iran, I love the comment that everything is code. And so the platform is just one more piece of code and treat it like code. That was when DevOps became useful. The software engineers talked to the operations people and they said, well, if I could, solve your operations problems with code, I'd do this. Well, why don't we do that? And they just started working together. Get the people together, solve the problems together. It's going to lead to a better outcome. I think I said that like 10 minutes ago in the podcast. So I'm going to get us to a kind of a wrap-up topic because I think we've hinted at it a few times. The idea of these classic concepts in software engineering, software architecture that just keep coming back. We mentioned it with the cell-based architecture. Not a new idea, but we're using it. Domain-driven design, you called out, was a good thing for teams to start using. The book's 20 years old. Let's start following those ideas. People came up with some great ideas in the 70s that we're finally able to implement because we have the infrastructure and the tools and the cloud and whatever else available. Love to hear some thoughts about that. Blanca, you can go first. What do you see as some ideas that have been around forever that people are like finally latching onto?
I think for me, it's been going to microservices, then going the other way back. And now I kind of like, I think what we were calling like right side services, because we're in a time that, hey, companies are ever more conscious about the costs of, the tech that we run. Architecting things, thinking of the now and near future, but not thinking of, a scaling for the next, few years. So I think that's been kind of the bigger thing for me and how that is also applied in data, where data workloads can vary enormously. So how can you build those data architectures in a way they can scale without spending too much money? So you can maybe cater for some, big days, but you're not kind of basically paying with your wallet upfront too much.
Rafal, what do you think?
Yeah, so I think it's good that we are talking about it because, it's certainly a recurring thing. And obviously, as architects, we've been experiencing the evolution of the IT industry. I think things come and go, but the fundamentals remain the same. And I guess this is important to understand. Whatever we are doing is actually perhaps more important to work out what it is we are trying to achieve first in terms of the actors maybe and interactions between those actors in the system, sort of on paper, really, without referring to any technology choices. I think people, always have been and are still quite drawn towards jumping into what we call solutioning and trying to apply a well-known pattern or maybe popular pattern to a problem without necessarily considering what is the end goal of the initiative or the exercise we are trying to achieve. So I think it's always important to make sure that we cover the basics and we get the foundational elements right before talking technology choices.
Ron, your thoughts?
Yeah, so I think it all comes down then to what Daniel mentioned earlier, and probably everybody else, coupling and cohesion. So basically how you decouple your systems, what are the boundaries of responsibility, and so on. And I think my greatest lesson from all this journey to microservices back is don't design by hype. So always know what's new, know what's modern, know all the new stuff. Like new technologies can make your life much easier, but don't design by them. Always think of these basic principles and design according to your non-functional requirements or quality attributes, things that you need to achieve now with an eye on the future. So maybe you'll have 10 million customers in a few years from now. Don't design for that if right now you maybe 100, 1,000 customers on a good day. Don't go with all the complex technology. Do something simple. Make it so that you can evolve your architecture and modernize it over time and pay the price for it whenever the price is justified. And so I think we always need to keep those basic principles in mind and then look at all the new stuff that's coming out all the time.
Daniel, you're up.
Yeah, fantastic comments by everyone. I think as I've got older and hopefully a little bit wiser, right, I sort of have two tracks to my learning. There is, as Aaron mentioned, the latest hotness. I just love learning, like as again Raphael mentioned, Blanca mentioned, because we're part of this QCon InfoQ community. Like naturally, we love like learning. We have the growth mindset, right? So we are just constantly like, what's the latest hotness? But I think there's another sort of dual track to that. I'm always trying to refine the classics, the timeless patterns, and particularly in my consulting career, like I really find myself falling back onto models, onto patterns, and all these kind of things. And I definitely think like a whole bunch of stuff we've talked about today is around like David Parnas's stuff, which I think is 60s, 70s, information hiding, again, coupling and cohesion. And I've had some really interesting conversations with a couple of folks of late, and they're like, stuff from the 70s, like that's really old. And I'm like, it's classic, right? As in we're building on all this stuff. I like to think we are making progress, but I think someone said it to me, it's almost like a spiral we're going around. Do you know what I mean? We're not making like, maybe actually you said this, Thomas, we had a sort of private conversation or whatever, and it's not like a perfect like up and to the right situation, but we are spiraling in the right direction, if that makes sense. I hope it works for the podcast, but we sort of are continually building upon what we've learned, but it's not always in a straight line direction. So for me, it's always that learning the latest hotness, looking back. Like I really enjoy reading the classic books, and I've already taken a couple of notes tonight. I've not heard that book you mentioned, Raphael, which is fantastic, but like building on the classic patterns as much as keeping up to date with the latest hotness too.
Yeah, I think one of the topics we didn't get to in today's discussion, but was on our list, was edge computing. And we were talking about this, again, before we started recording off mic, the idea of run your code where it makes sense. Push it to the edge. I think, Blanca, you were going to say that way save costs. People are finding these ways. It's not just about distributing the resources, it's running at the right place. Well, that's not a new idea, right? Like we had mainframes because that was where the server was and you had a dumb terminal. And then everybody got PCs and all of a sudden we pushed all the code to the PCs. And then, well, let's put it back on the servers and we're going to go back to these web-based machines. And the web interface was just straight HTML. All the processing was on the server. Oh, well, now we can run JavaScript and it won't crash my browser. Put the code back on the client. Like it continually goes back and forth in that spiral. And I think I saw that slide at a conference in 2005. So that's a 20-year-old idea of that spiral of going back and forth. And we're still talking about it today. So keep reevaluating. The reason we have those swings is because we keep finding new ways to do it because our requirements change. So some of the reason for distributed as a smart client web app or whatever you're going to do is how do I deploy my code? And this gets to the idea of platform engineering. How do I get my code to the customer who needs to use it? Those are things we always have to think about. So what's the new technology that's going to make it easier for me to get my code out faster to market, faster to the customer, more useful, less latency, all those things. Keep going back to the classic basic understanding of what makes good architecture, what are your quality attributes, what are you trying to achieve, and what you may have used 5 years ago probably isn't the right decision today. And what might be the right decision today may have been closer to what you did 10 years ago. So don't throw it out just because it's old. Sometimes it's classic. Any final thoughts people want to throw in before we just wrap it up? Anything we didn't talk about? Thing I'm looking forward to in 2024?
I do think, to Blanca's point off mic, the sustainability and green revolution is really important, right? We talk a lot about sort of ethics, I think is really important for AI, but we've got that covered in another podcast. I know like Shane and the team Cultural Methods have looked into a lot of that. But I do think like we're seeing, I've got to shout out a few folks like the QCon, I think we've got a track this year, QCon London, focusing on sustainability, run by Anne Curry. And Anne's awesome, has been banging that drum for a long time. But Adrian Cockcroft jumped in the mix, a whole bunch of folks are looking at that. So Blanca, I don't know if you're involved in that track or you looked at that track, but I do think the green software push is really important, right?
Absolutely. I am not directly involved in that track, but I am part of another architecture track. And we're also going to be touching on green software because it's such a big topic. And I know there's some books, one from Anne Curry, that are coming up soon. So I'm looking forward to that.
Rafal, anything that you're like really looking forward to, new stuff in 2024?
Well, I think it's certainly quite exciting in AI space. I think there is a fair amount of hype. I just want to see, I think, more of applied uses of AI beyond generating things from other things, I guess. So I think we touched a little bit about it. More customized or tuned applications of AI and AI-based products that are, addressing specific needs. And I think this is happening, obviously, partially through the automotive industry. I think there is a lot of investment, a lot of research in that space, and some other areas as well. So inevitably, it will be happening. I'm pretty sure that it's going to be impacting us more and more. And I'm certainly suspecting that the trend, I guess, or the evolution that, for instance, machine learning has been going through and what we call MLOps these days, I think maybe in a year or two we'll be probably talking about AIOps, because there will be products and architectures that are either driven or powered by AI or certainly AI enabled. So we'll be contending more and more about how best to incorporate AI into things that we are building.
And Iran, final thoughts for what's coming forward in 2024 for you?
So I think we pretty much covered everything, but to add one more thing that we didn't touch, which I'd like to look at, is the concept of privacy engineering, which we didn't get to discuss like today. But basically it's the idea of how do I incorporate our users' privacy into the architecture of the system. So it could be simple things like don't log personal information of your users into your log, which is kept for I don't know how much time. Or don't store information that you don't really need. Like ask yourself, do I really need to store this information? And like the best way to protect it is not to keep it. But it could be more complex topics, like if we have users' data and we need it for analytics, like how can we protect our users' privacy it could be by anonymizing it could be by aggregating it could be by removing some of the data. And like I mentioned, data is part of things that architect needs to do and needs to be aware of. I think it's one of those things that we'll see more and more, especially as regulation like keeps piling up across the world and to handle all kinds of topics around that area.
You guys covered everything that was on my list we didn't talk about, so I'm not going to add anything. I'm going to say thank you to everyone for joining us today on the podcast, contributing to this discussion, and a reminder to the readers that this is just half of the InfoQ Architecture and Design Trends Report for 2024. The other part, the printed report, the written report, including the fabulous trends graph, will be available on InfoQ.com the same day that you can hear this podcast. So we hope you go download that, check it out, and share it with your friends. And we hope to see you again on a future episode of the InfoQ podcast.